Hello and welcome to episode 113 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
I'm Andy.
And I'm Popey, and I'm Alan.
Good to talk to you all again. And welcome to the show, Popey. It's great to have you.
Thanks very much. It's nice to be included as a developer.
Yeah, you are a proper developer now.
Kind of.
You even said so the other day, I think. So what we want to talk about today is software packaging. And I have this sense that it's quite a hard thing to do. And you, Popey, have got quite a lot of experience of packaging software. For years, you were involved with snaps, and then you weren't involved with them, and you kind of took a bit of a dim view of them for a while, but then you seem to have kind of mellowed on that a little bit.
My packaging experience goes back beyond snaps. I used to do a fair amount of deb packaging, maintaining PPAs and stuff like that. And then I did a lot of snap packaging over the years. And I think Debian packaging is hard for a couple of reasons. And that's what leads into the advantages of the containerized new formats like AppImage, Flatpak, and Snapcraft is the fact that you could, with a deb, you generally need to build a deb per architecture, per release, and per distro. And that means you've got to maintain metadata for a lot of different things. The more distros you support, the more releases you support. If you go back like 3 LTSs, that's a lot more work. It's just more stuff to do. And Debian packages are quite complicated to do by hand. And yeah, I did a load of snap packages as well. But I think, interestingly, I've also done since then some packages for other platforms. I've even made packages for the Winget repository on Windows. And I've made packages of Go applications and a whole bunch of other stuff, Rust applications and all kinds of other stuff. And I think the thing we've got to now is so many of the software ecosystems now have the tools already made. And this is something we didn't have a long time ago. Like now, if you build an Electron application, it can just spit out packages for every platform and you're done. You don't have to get into the weeds of how to make a Debian package or a Snap or a Flatpak or an AppImage. It just has all that knowledge built into the platform. And the same for Go. There's a tool called Go Releaser that can create the packages for you. And there's a tool that can turn a zip file containing an executable into a Winget package. Like there's helpers now. And I think that's taken away quite a lot of the pain.
I think you hit on it there perfectly, but it encompasses so much. And like as a developer, when you're building the tool, there's so much to consider, like not just the format of the packaging, right? Like what's going to go in it, whether you're going to have documentation and licenses and all that other stuff. But there's also considering the libraries. Are those provided in the bundle with the package? Are they provided by the system? Is this supposed to go with another system? What's the libc that's going to be a part of this? What version of libc is it going to be? So there's like all these like different considerations that go into packaging, and each one of the formats I think does it slightly differently. And as we've modernized or whatever you want to call it, some of the newer formats or some of the language-based ones try to incorporate all that together, and it's hard.
It's also, there's always like the Sinclair Spectrum versus Commodore, and there's the GNOME versus KDE, and there's all that, stupid rivalry in the user community that developers generally aren't like that. And there's similar like that in packaging, and it is as ever thus. It has always been that way for packaging stuff for Linux. Like if you look at the Linux distribution chart, that big thing that's a tree on its side where, there's 3 distributions in 1993 and then it fans out to Ubuntu, 1,000 versions of that and 1,000 versions of Fedora. There was always competition and there was always different ways to do it. And they all have advantages and disadvantages, but they're all different.
But it sounds like those differences matter a lot less these days than they once did because of the tooling.
So I think it kind of depends on whether you're packaging something for a distro and, low-level stuff where, as you said, Kevin, you have to take care of things like libc and all that kind of stuff. Whereas if you're packaging a Leaf application, a lot of that kind of stuff is abstracted away from you. You kind of have expectations. Like when we package up Go applications, we just assume Go Releaser knows the right thing to do and that binary that comes out the other end is going to run on anything. We don't test that binary on every Linux distribution because there's some level of assumption that somewhere in between the Go binary that's built and the package that's made by Go Releaser, there's some stuff in between that and the metal that like does all that for you, and we don't have to worry about that. So we can ship one binary and it works pretty much everywhere.
Were you telling me you don't have a CI pipeline for Slackware?
I filed a bug that said I think we should support BSD for one of the applications just because lol. And I nerd sniped someone into actually trying, and then they ended up installing a BSD VM in order to test it. It's ludicrous.
When I'm picking a technology, I'll be picking it most likely for how easy it makes my life to like write the code and run it on my local machine and stuff like that. And some of the new languages like Go and Rust and Zig end up with this statically linked executable that contains a lot of stuff that would previously have been packaged in apt. So what's your take on that? Is that helpful for packages, or is it unhelpful, or do you think it doesn't matter either way?
I love it. Whenever I see a project that's new that someone shared with me and I see, oh, it's Go, then I know I'm going to have no problem whatsoever building it. First, I go build and point at the directory or go get, and I've got it, and I've got a binary and it will work. And the same with Rust. Like I'm relatively familiar with how to build a thing, but that's just building it. The tools that come with those languages and those ecosystems that spit out a deb, I am pretty confident that deb will install on any system I've got. All I've got to do is scroll down, and if I'm on my Mac, I look for the ARM64 deb, and if I'm on my PC, I look for the AMD64 deb, and I don't really think about it. Now, caveat, I'm using Ubuntu, which is quite widely adopted and quite widely used by developers and users. And so I can imagine if I was using a bespoke niche distro, my experience might be different. But because I'm kind of mainstream, it's not a problem for me.
So that's the thing that's top of your mind. Like basically, will the deb work? Is it ever in your mind of like, oh, actually, I've packaged something that might be a repeat of some other stuff that's already on my system and there might be a security hole in it, or do you not care?
From a security point of view, I do. I work for a company that makes security tools. So yes, that is a thing I do care about. But from a point of view of what if there is more than one copy of libz on my system? No, I don't care. I've been through building snaps where across 10 different snaps that are on my system, I have 6 different versions of LLVM pipe or something like that, and which is a gigantic library. And I've got 6 different compressed copies of that on my hard drive. I don't care because those 6 applications or those 10 applications with 6 different versions all work. Mm-hmm. And disk is cheap and I don't really care. And I think it's a personality thing. Some people like the pristine, tidy desk analogy of, I know exactly where every file on this file system came from. I know what they are. The origin, I can trace it all the way back, like a Nix user would. I can trace it all the way back to, the fingertips of the developer that created this thing. I don't really care so much for that on my systems, but I can see how enterprises do and want to know the origin, like the supply chain, the software supply chain of everything. But yeah, I'm less bothered about the fact that there's 3 versions of bubble tea library compiled across 3 different Go binaries. I don't care.
What about reproducibility? Is that something that people care about yet?
Do some people care about it? Absolutely. There's, I would say, a decent number of people that care about reproducibility, but it's also one of those things that's so much harder to do, practically speaking, than it is in theory, because it's not just compiling with the same libraries and the same architecture. It can even be trying to eliminate timestamps from build artifacts. And there's just so many things that go into making a reproducible binary that I think even projects like Nix and other ones similar to it have a hard time making truly reproducible builds. Like they can do that for the most part, but there are still edge cases and areas where they're not able to because there's just so much to consider.
I really care about it, and I would like to make a formal thank you to the F-Droid project for putting me through the agony of making my builds reproducible.
As well as all the individual software packages, there's a lot of, in the world I work in, a lot of containers. And these containers contain even more of that duplication. So, you've got 5 different containers where an application is split across, multiple different microservices and a database and other parts of the application. And you might have many copies of Python on your system as a result, and many copies of a whole bunch of Python libraries on your system, and whatever else was compiled, like C libraries that are required by those Python libraries inside each container. And I know there have been attempts to slim down those containers, like Slim AI did that. And I know Canonical are doing a thing where they're calling it chiseled containers, where they chisel away. That's the term they use, using their tortured analogy of Roxcraft, which uses chisels to carve away these. It's horrible. But the point behind it is you can chisel away the bits you don't need and leave the bits you do. It takes some expertise to do that, but there's some drive to make containers faster to start and for you to be able to very explicitly know what's inside that container, like every single file, where it came from, who built it, what version of the source code it came from, what tag it was, who touched it, did anyone from this nation state touch it or not, and so on. And there's a lot of that going on in the industry. And so there's a lot of people trying to slim down to that you were mentioning, Andy, about not having these duplicates all over the place and being able to know the origin of everything.
Yeah, like a deb.
Well, so the interesting thing about a deb is, do you know the origin of it? So if I do a Docker pull some container from a container registry, that may consist of multiple layers. And if you look at the Docker file, if you have access to the Docker file, then it may be that there are lots of operations that have happened where software has been added and then some stuff was built and then some stuff was deleted and then some more stuff was added to build another part and then that was deleted. And so what you end up at the end, there might well be a deb in there somewhere with all the Debian metadata from varlib dpackage or wherever it is wiped. So you can't really tell where it really came from unless you have the Docker file that built the thing. And even then you got to work backwards.
And you've got to know what day it was built, because it might have pulled down a different version on a different day. That's what I mean by like a deb is, if you eventually slim down Docker images enough so that you know exactly what's in them, you'll have equivalent of a deb, right?
Well, a containerized deb. Yes. A containerized deb that works across different versions of different Linux distributions and could even work on a Mac, for example. Like I can Docker pull a Linux thing on my ARM64 Mac OS machine and it works. So yes, like a deb, but works.
But what is a container if it is not a software package? It is literally a package of software. I mean, it's conceptually different from a deb in some ways, but in other ways it is, I download a thing, I run some software.
Yeah, I mean, grab the Nextcloud container, do a Docker pull Nextcloud :latest and have a look at what's in there. It is an amorphous blob of every package you can think of. There's Python packages, there's NPM in there, there's debs in there. It's based on Debian, I think. There's a whole load of stuff in there. And that's, not trying to be an advert for the open source tools that I work on, but that's where you use a tool like Syft, SYFT, open source tool that can create an SBOM of what's inside that container. So you can figure out, are there any vulnerabilities? Where did all these things come from? What's the origin? Are there any files in here I don't recognize? That kind of stuff. And yeah, it's not just a deb, because a container, like some of the containers we scan are like 10, 15 gigabytes in size and contain jar files that contain jar files that contain jar files all the way down. And so it's scary what's inside some of these things. And you have to be able to audit this stuff. Otherwise, how are you going to know where it came from and who made it? And yeah, like you say, what time it was built and what repo it was pulled from.
And even what compile time options were used. Was it built using, some of the position independent code or position independent executables? Like there's all kinds of like little options that get set when these things are built for package repositories or for some other of the newer tools where they get built and then packaged up into, whether it be the, deb, app image, whatever it is. They'll, like all of these options are picked for you. And those things matter for not only reproducibility, but also knowing like what was pulled in. Because if you have a compile time feature that turns off a large swath of libraries, maybe those were not pulled in. Like there's all kinds of stuff that it comes down to when you're packaging.
Yeah. And to be fair, like you could probably find the origin of many of these packages, like that they were originally built on Launchpad, for example, or they were originally built in the Debian build system. And you could probably find the original maintainer somehow, the changelog and, the control files, and find all of that stuff. But in an environment where you have a complex set of containers and you've got developers working on software and they just pull in random debs from all over the place. Oh, I need a copy of that thing that's newer than the thing that's in Debian, and I need a copy of that thing because this depends on it, and I can only get that from the upstream repo, and I have to depend on this other container. It is quite a nightmare, the complexity of the way software is delivered now. That isn't anything like, apt install cowsay, and that's all you're doing. It's a lot more complicated than that, and it's a mix of different languages and ecosystems and everything.
Aren't you just making an argument for not allowing Docker containers on any system?
Well, I was very much anti-containers, Docker containers. I just didn't like it. I've only recently started actually enjoying the process of containing software inside something like Docker or Podman. Like, that's fine. But there's a lot of similarity between things like Docker and Snapd and Flatpak and AppImage. It's all much the same thing. I remember going to a KDE Academy, probably 2018 in Vienna, I think it was. And we were talking back then about snaps and flatpaks, and the KDE developers, who have been around a long while and have seen all these things come and go and all the different package types, were very sanguine about this. It's like, it's the same old story. We're just packaging them in a slightly different way. It's the same bits. We're just packaging. And they were very chill about this kind of stuff. And I try and adopt that kind of attitude about this stuff. It's just putting software in a zip, basically.
That was the key differentiator for me when I was first learning about containers, was stop thinking about them like VMs and think of them like a giant tarball with all the things they need. And you're just running one of the programs in that tarball to start off with.
Yeah, you can even run Docker save and it will spit out a tarball of the whatever was in that container, and you can stash it away somewhere. It's just a box with some stuff in it. That's all it is. It's all the metadata around it and all the policy around it. And you look at the Debian packaging guide, and then you look at the fact that snaps only have one store, and Flatpak is this giant set of repositories with a community around it. And it's just software on disks. It's not that hard, and it's not that controversial, really, I don't think.
But there is a kind of a line, isn't there, between packaging systems that are like a tarball plus a list of other tarballs you need, versus packaging systems that are just a tarball with everything you need in them.
You've quite a bee in your bonnet about this, haven't you?
I'm not saying one is better than the other. I'm just saying there are two different types.
You are saying that devs are better and distro repos are the way to do it, and you hate the future.
I've already played my cards. I don't know.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at linuxdevtime.com/support.
When I worked at Canonical, one of the things we would get a lot was, you're going to replace everything with snaps. Everything is going to be a snap. And step back, bro, because if you look at pretty much any snap, it contains debs. They're made from debs. It's like, you're going to replace atoms with this other thing. It's like, no, everything's made from atoms, right? That's the thing these things are made of. Now, okay, you can make a snap which is just, you got a binary and you shoved it in a snap. Or you can make a snap where you got some source code and you told make to make it, and then you just put it in the snap. And so you end up with a squashfs file, and in that is a bit of metadata and a binary file, and you've got no idea where that came from and who built it and whether it's got any malware in it. See my blog posts last year. But for the most part, unlike the Go binaries, a lot of these pieces of software depend on libx or libwayland or a game that needs libstdl, and ain't nobody got time to rebuild all of that from source. So you rely on the packages that are already there because they have security guarantees from the Canonical security team. And so you rely on those. I can't see debs going away anytime. And I've been saying that for 8 years, and it's still true.
They haven't gone away, that's true.
No. And I can't see any reason why they would, because there's pieces of the stack that make no sense to make as a Flatpak or a snap or an app image. It makes no sense to package, I don't know, libpython numpy as a snap. Because on its own, it's useless unless you have a whole bunch of other stuff around it and you've got an application built on top of it that needs that library. It doesn't make any sense. And so all the naysayers who used to say to us, oh, you're replacing everything with snaps. It's like, well, some things that make sense, yes, but lots of things don't make sense. And so we don't do it. And so I can't see Debs going away anytime soon.
That's an interesting point too, though, about the difference between packaging a library or, a system library versus the end user application. I wonder if that is also part of the divide between like some of these arguments, as in like most people just want their software to run. They want it to run. They want it to be secure. They want it to run reliably. The developers want their software to run on their user systems reliably and in the way that they made it. So a lot of these newer systems, Snap, Flatpak, all these different ones, they focus on that piece of it, like have the developer make the thing, and then the thing reliably runs wherever you end up running it on. And a lot of the older systems take into account all of the pieces, like all the way down to the Lego bricks. And you have to package all those things, the libraries themselves, which, like you just said, would not be well made as a snap or an app image. So I wonder if that has to do with some of the divide as well.
So 2 Ubuntu releases every year, and snaps started in 2014, 2016, something like that. So you do the math. How many Ubuntu releases made out of Debs have there been since then? They're still there. They're still made from Debs. And making a distro makes sense out of Debs. But also, making Chromium a snap and bundling in libx and all the other libraries to do the 3D and the X input and all the other things that a browser needs makes sense to bundle those Debs in there. So yeah, I think all the time, these containerized applications, whether it's Docker or Snap or whatever, are going to be a conglomeration of other things because Debs do really well at packaging libraries and system files. And pip is really good at packaging Python stuff. And NPM is really good at packaging giant gobs of JavaScript. And so any application that requires system libraries, a bit of Python, and some JavaScript is going to probably leverage all of those package ecosystems. And it's not just going to be one packaging system to rule them all, unless it's Nix.
But isn't the nirvana then to pull all the stuff you need from those various packaging systems into one containerized application then?
That's exactly what Docker is. A Docker file will say from Python 3.9. And so the Python project build a minimal container that contains Python 3.9. And then the very next line is apt install blah, 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 Node.js. And then the next line is run npm install blah, 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 blah. And so that container now contains Debs, Python packages, and Node packages, which contain JavaScript. That's just the way it works. And the same goes for Electron. An Electron app image will probably contain bits of Debs, bits of like JavaScript from Node, and all kinds of other random binaries. It's just the way it is. I've become so much more relaxed about software packaging now that I don't have to do it. And that tools are made to make my life easier. And like you said, it makes the user's life easier because they can reliably click on a Deb in a Git repo or in an archive or in a store and it will install. Or they can reliably download a thing from whatever graphical front end and it will install and run. And from a developer's point of view, you can build it more easily without too much stress and without having to read a 500-page Debian packaging guide.
Yeah, in a previous company, we had a cross-platform application that we made, and it was Windows, Mac, Linux, and very similar. It was a kind of like Electron. It's a thing called Tori, and it uses some JavaScript on the front end and Rust on the back end. Super, super cool project. However, in that they also have tooling that spits out like an app image, a snap, a deb, an RPM file. And so we moved from like, hey, we started off with just a tarball that the user could run. And then we moved into, okay, now we provide these packages based on some automated tooling. And then we'd have some users say like, hey, I want to run this on Ubuntu 16.04 or something. So there might be a little bit of work to do that, but it was kind of a sliding spectrum where we would move from like easiest for us to get the most of our users and then sliding depending on like if we had enough users that cared about a more niche or older system, we could move into more I guess, specialized, but more traditional style packages. And that seems to be the way, I guess, a lot of projects are starting to move now, which I personally think is a good thing.
Right. And it's also how much resource you've got to QA this stuff.
Yeah.
I filed an issue against one of our projects called Grant, which is just a utility that you point it at a container or a directory and it will scan all the packages, or you point it at an SBOM and it will scan all the packages and tell you what licenses are being used. And you could say only allow OSI approved, or only allow GPL, or do not allow GPL. And then it will produce a list and it will either pass or fail, saying, no, this has got GPL in it, or no, these packages are not OSI approved licenses. And so I filed a bug against Grant because it's only packaged for Linux, I think. There might be a macOS binary, but we didn't switch on the build of Windows. Now, all we got to do is like flick a switch in Go Releaser and we'll get a Windows binary out, right? And it's easy. But has anyone tested this thing on Windows? No. And who's going to do that? None of us, because none of us have Windows machines. And so we have like a long-lived Windows machine in the cloud that we might spin up and poke. And I will spin up a VM using QuickEmu, which is a fabulous tool. But that's not always super reliable. And so I've been testing on my gaming machine here at home because that's got Windows on it. And I can test these pieces of software on a Windows machine. And so, you've got to figure out, is the investment worthwhile? All these stories you see about game developers who release games, they're going to get the biggest bang from all the Windows users because there's so many of them. And it's the same for like tiny little utilities like this. I don't know how many users there are potentially for a license checker that runs on Windows. I don't know. Maybe we'll get tons of downloads if it's available. But once we've got a better QA system, we will probably enable that. But, slowly catch your monkey.
It feels like the kind of person who would use that on Windows would have WSL installed.
Yeah, probably. Yeah. In fact, I submitted Grant to Winget, and this was a revelation. Someone filed a bug against one of our pieces of software and said, your software is out of date in Winget. And I was like, what's Winget? And then go and have to look at it. And oh my gosh, it's a giant repository on GitHub, one folder per application, and there's loads of stuff in there. All the applications you've ever thought of are in there. And I thought, I wonder what it's like to update this. So I looked at one pull request that was updating some other random piece of software, and the pull request had boilerplate in it that said this pull request was built by, and then the name of the software, which I can't even remember. So I went looking at that software and I thought, oh, this looks quite good. I download it. It's a command line utility. You literally just run it and point it at the zip file that contains your Windows executable, and it repacks it and gets all the metadata and then makes a pull request in GitHub on your behalf and sends it to that Winget repo. I was just like the monkey flipping the switch, and suddenly I've packaged something for Winget. It's magic. So yeah, packaging is a ton easier now with these utilities.
Right, well, we better get out of here then. Thank you very much, Popey, for joining us. It's been absolutely great having you.
You're welcome. It's lovely to be considered for a show like this, which is full of actual developers.
Well, developers and me. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
I've been Andy.
And I've been Popey and/or Alan.
See you later.